All right, so this is 7.1 part 2. We just started chapter 7 here. We talked yesterday about scale factor. Remember that? We talked about similar shapes in that they're the same shape, but they are different sizes. So an enlargement, this triangle on the right here is an enlargement of the triangle on the left. And if that triangle were smaller, then it would be this is what we call a reduction. So something that's smaller is a reduction. Reduce, reduction. Enlarge, getting larger. All right? So today as we continue, let's take a look at example 2. The cylinder needs to be enlarged by a scale factor, thank you, of 5/2. Find the dimensions of the enlargement. Hint, write the scale factor as a decimal. That might help. Okay. So you know how to work with fractions. You know how to multiply fractions, which is fine. You might want to write it as a decimal. It doesn't really matter. You can leave it as a fraction as well, but still I feel like this needs to be zoomed in a bit so you can see it. All right, a little bit. Okay. You guys see that? If you want to knock a light off, you can there in the back. It's up to you if you can see. So if we write this as a decimal, what's the decimal of 5/2? Anyone know that offhand? You could actually do that in your calculator too, but yeah, what is it? Yeah, it's 2.5. And you can literally do 5 divided by 2 on your calculator if you don't know. So 2.5, sometimes it's easier to use your calculator and work with a decimal than a fraction. I get it. So you might want to convert your scale factor to a decimal if it's not already. So the situation that we have here is we have this cylinder, and we have a diameter of 3. Notice that's a length. That's a part of the cylinder. That's a length. That's good. We're not talking about angles or anything. And a height of 7. So that's another part of this cylinder. That's a length. That's great. So how do we find the dimensions of the enlarged cylinder? So consider we're going to multiply everything by about 2.5, and it's going to be bigger, maybe like this. That might be 2.5 times as big. Okay. So we want to know what is the diameter and what is the height of the new one. Okay? That's what this says. So we've got a decimal, which is nice and easy to use on the calculator. Then what we want to do is we want to multiply each dimension by the scale factor to get the dimensions of the enlargement. Really easy, really, really easy. So the original diameter is 3 centimeters. And so what we're going to do is we're going to multiply 3 times 2.5. And that becomes 7.5. And specifically, it's 7.5 centimeters. So the diameter of the new one over here is now known, and that is 7.5 centimeters. Everybody okay with that? Any questions about that? Pretty easy, right? Take the measurement, multiply scale factor. The measurement that you're given, multiplied by the scale factor to get the new measurement. Okay, so 7, we're going to go 7 also times 2.5. And that's going to give us, let me do that on your calculator. Sorry, my notes just disappeared. Come on back. Try that again. 7 times 2.5. That should equal 17.5 centimeters. Apparently not. So the height of the cylinder is 17.5 centimeters. 17.5 centimeters. All right, so 3 goes to 7.5, and 7 goes to 17.5 when we multiply it by 2.5. So we have diameter equals 7.5 centimeters, and the height is 17.5. All right, any questions about that there? Pretty easy? All right. So if you're going from original to a scale diagram, just multiply by the scale factor and each corresponding length of the original diagram. All right, example 3. Let's take a look at this one then. A photo has dimensions 10 by 15 centimeters. All right, if you want to sketch that, that's a good idea. Always a good idea to make a little sketch. And we have 10 here, and we have 15 here. So it's a photo, 10 by 15. 2 enlargements are to be made with each scale factor below. Find the dimensions of each enlargement. All right. I'll do the first one with you, and then I'll get you to do the second one on your own. So 10 by 15, that's going to be enlarged, and so the scale factor is 4. So what we do is we take each dimension on the original, and we multiply it by the scale factor. So that's going to be 40. Okay, so the original width, is 10 centimeters. The enlargement width is 40. Working down, the original length is 15 centimeters, so we're going to do 15 times 4 is going to be 60. So that's 60 centimeters. Enlargement dimensions, 40 centimeters by 60 centimeters. And in this section, we're just calculating enlargements, so we're not going to work with reductions just yet. That'll be next section. So this is pretty straightforward, right? Okay, why don't you do B on your own, and then I'll show you my answers in a minute, and you can compare and see if I did it right. Okay? So B, we have a scale factor of 13 over 4. So how would you make this photo right here? How would that be enlarged by a scale factor of 13 over 4? What would be the new dimensions? So go ahead, take a moment to work on that. So your dimensions should be 32.5 centimeters by 48.75 centimeters. Any thoughts or questions about that? Do you guys get that? Now, if you don't want to convert this to a decimal, you don't have to, right? On your calculator, you can use just the fraction, 13 over 4. On your calculator, that would look probably a little bit funny on your calculator, perhaps, I don't know. But if you went 10 times, some of you have is it frozen still? Sorry. Some of you have a fraction button, some of you don't. So on this calculator, I would just have to go 13 and then write the divided by 4 in brackets. So you could do it just like that too, and you get 32.5. All right. So sometimes your calculator might give you a fraction. That's okay. Usually decimals are fine. Fractions for lengths are okay too. But usually decimals are a little bit easier to work with, especially when we're able to use our calculator. All right, so we wrote this yesterday in yesterday's lesson, but just remember that all enlargement scale factors are greater than 1. So if you see a scale factor that is 7, that's greater than 1, you know that the scale diagram will be bigger than the original. If you see an if you see a scale factor that is less than 1, and specifically between 0 and 1, so like a decimal or a fraction like 2/3 or something, or 0.4, that is a reduction, and we'll study those next. Okay? So all enlargements have scale factors that are greater than 1. All right, I'll give you your 7.1 assignment. All right, so assignment 4 to 7, 11, do all of 11 A and B, but just do the first part, the letter I, so the Roman numeral 1 there. That's the first part. Identify scale factor, and then 12. So I want to do 4 with you. Let's do 4A. It says determine the scale factor for each diagram. Okay. So this is a question. I don't know if we've done a question exactly like this in our examples. So let's see if we can figure it out. Here's the original. Here's the scale diagram. Obviously, the scale diagram is larger than the original, so this is an enlargement. We should expect the scale factor to be greater than 1, right? And how we find scale factor, remember, scale factor is the scale diagram length over original always, right? The original is always on the bottom. So when we figure that out, then we can now plug in just lengths. So a good idea to take, let's say, a side length like this on the original diagram, which this appears to be 2 units. Okay, you count that 2. And the corresponding side on the big diagram would be this one. So we'll count those. 1, 2, 3, 4, 5, 6, 7, 8. So if I were to calculate this, the scale factor is going to be 8 units divided by the corresponding side on the original, which is 2. So it looks like the scale factor is 4. Now it's greater than 1, that makes sense. And I would multiply 2 times 4 to get 8. So everything seems to be working fine. Everybody understand that? Get that? Okay, what about B? Well, we've got 1, 2, 3, 4 here. And the corresponding side I can identify as over here. 1, 2, 3, 4, 5, 6. Okay, so the scale factor is going to be 6 over 4. We should reduce that. Please get in the habit of reducing all fractions. And if you want to write this as a decimal, I'm okay with that too. So this would be what? 3 over 2 or 1.5. So either of these would be fine. Any questions about 4? All right, next one you want to do is number 5. So let me just get you started on number 5. Scale diagrams of different squares are to be drawn. The side length of each original square and the scale factor are given. Determine the side length of each scale diagram. So in our original square, we have a side length of 12 centimeters, and the scale factor is 3. So to find the new side length, what do? We multiply them together. Exactly. The side length of the original times the scale factor. 12 times 3 is 36 centimeters. Make sure you have your units. That's your answer for A. Now, I want to show you something. The reason why we just multiply side length times scale factor, notice this. The scale factor definition is scale diagram, side length divided by original side length. So if I wanted to find out what this equals, the scale diagram, what that equals, then I would multiply both sides by the original value. See? So that is the scale diagram lengths equal, because the originals, now this is gone, equal this. The original side length times the scale factor, which is what we just did. Original times scale factor. So that's kind of how we can rearrange the formula, or the formula for scale factor. You can rearrange that to find out what to do. So we'll work more with that as we kind of improve our algebra skills as we move on here. But yeah, it's original side length times the scale factor. That's all you need to do. So B here, 82 times 5 over 2. So if we know how to work with fractions, 82 can be simplified with 2. That's actually 41 over 1, if you wanted to do that. And then you could pretty easily multiply 41 times 5. 40 times 5 is 200. So 41 groups of 5 gives me 205. And the units will be millimeters. All right, I'll let you finish 5 there. So number 6, very similar to the other photo one we did. We have an original photo that's 17.5 centimeters by 12.5. Enlargements are to be made, so basically find out the dimensions of the new enlargement. So if a scale factor is 12, that means we multiply each of these by 12. It's as simple as that. Each of them by 12, and then find out the new dimensions. So for A, 17.5 times 12, and 12.5 times 12. You can get your calculator out and do that pretty easily with the calculator. So 17.5 times 12 is 210, so 210 centimeters. And then 12.5 times 12 is 150. That make sense? How'd you do with number 7? Number 7, you actually have to measure to the nearest, measure to the nearest millimeter. Hey. Measure to the nearest millimeter the actual length of that fish on the page there. So they give you these lines, which are really nice. Just measure from this line to this line. Okay. So did you do that? Okay, 4.8 centimeters, or how many millimeters would that be? 48. Yeah, because that's the other thing, we got to make sure we are in the same units, right? So if this is 4.8 centimeters, which I agree that's pretty good, this number is in millimeters. So we have to make sure all our numbers are the same units. So that's actually 48 millimeters. Okay. So the actual fish, the actual length is 30 millimeters. So the actual fish is actually, looks like smaller than this scale diagram. Funny, huh? It's a pretty small fish. So measure the length in the diagram, determine the scale factor. So scale factor is scale diagram length divided by original length, right? Or the scale diagram length, 48 millimeters divided by the actual length, 30. So you can simplify that fraction or write it as a decimal. It's okay if you write it as a decimal, I think. So 48 divided by 30 gives you 1.6. Did you get that for number 7? All right. I'll talk to you about number 11 here too in a bit. Once everybody is there towards the end of class here, I'll maybe help you if you need it. Okay, number 11 asks you, with this shaded one here, it asks you which one of these A, B, C, or D would be a scale diagram of this shaded one, and then state the scale factor, okay? So what you want to look for in this case is you want to look for another diagram that has the same proportions or ratios of side lengths, okay? So remember, a scale diagram, each side length has to be multiplied by the same number to get the next one. So here's another way to look at this. This is 1 unit tall and 3 units long, okay? Now the other diagram in this that is a scale factor, or is a scale diagram, has to have the same ratio of side lengths. So this one has 1 to 2. So 1 over 3 is not the same as 1 over 2, right? You see? So you would times 1 here, and then you can't times 1 here to get that. So that doesn't work. So it's not this one, not A. So B is, the shorter side is 2 to 3. So 1 times 2 is 2, but 2 times 2 is not 3. Or 3 times 2 is not 3. So the ratios aren't the same. D, this is 2 and 5. So 1 to 3 is not the same as 2 to 5. Instead, this C over here is 2 to 6. So 1 to 3 is the same as 2 to 6. Or, thinking about it another way, look at this. 1 over 2 is the same as 3 over 6. A lot of different ways you could look at it. Okay, but this proportion, remember, has to be the same shape. So that means that all of the lengths of the sides in the figure have to have the same proportion to each other. So if you have, a circle, right, the diameter, okay, is proportional, but that's only one length. So if you have 3 things, like a triangle here, right, then an enlargement, all of the ratios of those would have to be the same. So 1 to 3, this one would have to be 1 to 3 as well. It has to be the same ratio, and so on. So those different ways you could look at it, but yeah, any questions about that?
I was just going to ask about 12B.
Okay, hang on for a second. Any other questions about 11 before we move on? Okay, which length to use? Well, here's where you just use your intuition. Like, this is the short side, this is the long side. So this is the short side, this is the long side. So this side is going to correspond with the other short side. The short side on the one is going to correspond with the shorter side on the other one. Yeah. Okay, any other questions about 11? Okay, 12 is the last one you have to do. I just had a question about 12, so really quickly. One frame of a film projector is about 50 millimeters high. The film is projected onto a giant screen. The image of the film frame is 16 meters high. What's the scale factor? So this is gonna be easy when we have these numbers in the same units. And here's where you have to use your metric staircase that we talked about last day. So if you think about this metric staircase, and you should have it in your notes there, I'll try and redraw it here. So if this is millimeters here, we're going millimeters to centi to deci to meters to deca to hecta to kilometers, so on. So millimeters to meters. Look at this. If I want to convert, let's convert 16 meters to millimeters. So I got to go down 1, 2, 3 steps. So that means I have to multiply by 10 3 times, or take 16 and move the decimal place over 1, 2, 3 times. So the two numbers we're actually dealing with here are 50 millimeters and 16,000 millimeters. So that should help there. That's all I'll give you there. But what is the scale factor? And then you can do B as well. All right? That's your start. Work on that for tomorrow.